Alright, so this time we are going to do a temperature indicator but with RGB LED. So let's scroll down and get an LED RGB from here. Let's just identify the pins. So there's red, there's cathode, there's green and blue. Let's just connect cathode first so there's less confusion here, and let's make it black. So now we know which one our cathode is. The other one is red, so we are again going to connect it with P0. Why not? Now here is the thing, this LED also needs a resistor. So I would say just pass on a resistor to it, 100 ohms. Right, and I would, instead of giving it directly to anode, pass it through resistor. I'll just make it a little bit more organized here. Yeah, that's much like it. I think Control C, Control V works, so I just tried that. There. Now I have my three great resistors. P1 I'm going to give to green. Let's identify whether this is green or not. Okay, when you have, yeah, that's blue, that's not green. Okay, I'm just going to move this here. Yes, this is green, so we are going to move this over here. Since this is blue, change the color to blue. See, the color is just for our reference. It makes for an easy reading so that when we code, we clearly know which pin is supposed to get an output and when. Now the code is pretty much the same that we did for the 3 LEDs, but let's do it again just in case you haven't done that one. How an RGB LED actually works is it has 3 LEDs inside it of a red, green and blue color, and you know RG and B are primary colors, so every other color can be made using RGB LEDs. It's not only for red, green and blue, but if you want to make purple, lilac, yellow, pink, anything at all, you can make it over here. I would request you all to try it out. Alright, so let's start with our forever. We are doing it to sense the temperature, so we will have an if block, and here it is. We need a comparison block, and from input we need temperature. So less than equal to 20, and we want only blue one to light up right now, so we will only give in 2 the value. Now here is the thing, I'm going to use analog right this time because it's an RGB LED. You can actually change the colors, make it, way better than the digital one. So I'm just going to write analog pin P2 to 255. Okay, yeah, just duplicate the one. P1 is supposed to be 0, and we also want P0 to be 0. Yeah, that's our first block of if. Just duplicate that, and we have that. We have greater than equal to this time, and we want it to be 30, but we want red one to light up. Red is attached to P0, so this one has to be P0 and this one has to be P2. Alright, and when you duplicate again, this time we want an AND block, which we can find in math, and we are going to change it to less than 30 and duplicate, and we are going to make it greater than 20. Alright, and we want then the green one to light up, which is at P1, so this one can be changed to P1 and this one can be changed to P0, and that's your entire code. Analog values for an LED varies between 0 to 255. Just remember that part. Once we start the simulation, you can see it's green right now, it's red when it's high, and it's bluish when it's down. You can change the colors. If you see why 0 to 255, even though it's RGB, it would probably work with high and low. But if you want to change in between and you want to use the secondary colors, and if you wanted to go for yellow, yellow is normally a mix of red and green. I don't know. Let's just try this. And it is for less than 20, so you can see a nice blue color, cyan. Yeah, that's cyan if you mix red and green. And if you do over here also 255, let's see what happens when it is greater than or equal to 30. We get it yellow. Okay, so yellow is P0 and P1, so yeah, red and green makes yellow, and P2 and P1 makes cyan. And we can have so we have done P0, P1 and P2 and P1. So I think we should do next P1 and P2. And so now we have secondary colors over here as an indicator, and it is yellow, cyan, and okay, no wait, I've made a mistake somewhere. Yeah, over here it was P1 and P2. We want P0 and P2. So this is 0 and this is 255. So when you start the simulation, yeah, that's more like it. Yeah, there you go. You have secondary colors over here. So RGB can do a lot more. All right.